about why everything is at 9.8. So first of all, in the last unit, we said everything falls at the same rate. And the reason we said is because gravity is constant. Okay? That's kind of hand-wavy. That's not a very good explanation. That's just kind of like, oh, because Mr. B said so. I want to give a better explanation than that. So G is always 9.8, even though the force of gravity is not constant. So this is a 10 kilogram ball, and we have a 2 kilogram ball. The one that's 10 kilograms is going to have a larger force of gravity. We'll call it FG10. And the one that's smaller is going to have a smaller force of gravity. We'll call it FG2. I want to know why the acceleration is the same if the force isn't. So if gravity is constant on everything, why is it constant on everything if the force isn't? The force isn't constant on everything. So the first thing we want to do is draw the diagram for each of the pictures above. I did that. I drew the two forces. Those are the only forces. Gravity, that's it. There's no other force. We're assuming no air resistance. There's no normal force because it's not sitting on a surface. There's no tension. There's no ropes. So there's nothing other than gravity. That's it. Okay. I want you to go ahead and calculate the force of gravity. So on your paper, go ahead and just divide it in half. Find the force of gravity for the 2 kilogram one. Find the force of gravity for the 10 kilogram one. Okay, go ahead and do that real quick. If you need to borrow a calculator, you can come do that real fast. But go ahead and calculate that quickly. Just multiply those two. Remember, the equation is Fg equals mg. All right. Force of gravity for 2, we've got a mass of 2. G is 9.8. So we get 19.6. Mass of 10. G is 9.8. So we get 98. Okay, I'm more confused than I was before, but I'm going to keep going. Clearly, the forces are not the same. So how can G be the same if the forces aren't? All right, we're just going to keep going. Solve for the acceleration of each ball. Use the second law relationship, which is A is F net over M. Use your diagram to determine the net force. So the net force is the force in the direction of the acceleration. The objects are going to accelerate down. So the net force is the force down minus the force up. There's only a force down. There's no force up. So the net force is going to be the force of gravity. So A equals F net. So for the 2 kilogram one, that would be 19.6 over M, which is 2. The other one is A equals 98 over its mass, which is 10. Okay, go ahead and solve and see what you get for A. Solve for each of those, see what you get for A. You got what? You got 9.8. All right, someone bring it home for me. How can these two things be the same if these two things aren't? How can the forces be different, but the result of the forces be the same? Reagan. Right, I'm looking for why. You're right, you're exactly right. It does not change how fast it falls, but why doesn't it? Because the force is different. If I pull harder on something, it should fall faster, but it doesn't. You're exactly right, it doesn't. So if I pull harder, why doesn't it fall faster? Why does it fall at the same rate? Tony? No, good guess though, but we're ignoring air resistance right now. There's something that resists change. What's that called? Inertia. Which one has more inertia? The big one. And which one has more force? The big one. The reason why the acceleration is same is because the inertias balance out the forces. The one that has more force has more inertia, so it's harder to move, but it has more force to move. The one that has less mass is easier to move, and it also has less force to move it. So they balance out to the same relationship, 9.8. So the way I like to phrase it is the heavier object has more inertia and I'll just put resists falling down. But also has more force. So that's its weight to balance it out. So a heavier object has more inertia, so it resists change in motion. It resists falling. But that same object with more inertia also has more weight, more force, and that balances out the inertia. And that balances out the inertia. So the acceleration is always the same. And why is the acceleration the same? Because the force of gravity balances out any inertia that the object has. Okay? That's the main idea that I wanted to try to get across here. Okay? Any questions on that? All right. Let's get started on the lab here. Looks like we should do okay. Timing, we go work in the back with Jonathan. And everyone else should be fine. Grady, you're going to be on your lonesome, but I have faith in you. Don't cry too much. Don't cry too much. No, he can't. No. Grady can't be helped. I'm just getting up on him. He's like, yeah, that's about right. That's how I feel. Anyway, so if you need help, just ask me. But it's a pretty straightforward lab.